Yeah, once again, good evening, everyone. Hope slide is visible to everyone, and am I audible? Right. So this is a continuation to the our first class. Okay. So apologies, there is a delay in continuation of this class. Okay. So now we are continuing the our previous class, that is mission operation and guarding. So it is, I can say, it is the part two for the chapter. So in this previous class, we talked about the definitions. What are the definitions related to basic definitions related to accident, injury, ill health, and also hazard. Okay, and so then we talks about the hierarchy of risk controls and how it is important. So those things, and so then when it comes to the syllabus, so this is the syllabus. I hope we covered this one. Introduction to mission coding and applicable standards and principles of mission coding we completed, and ergonomics of mission coding and types of cards. So up to this we completed, and so now we are once we review on the types of mission coding, then we complete this design and selection, mission specific coding, and safety devices and maintenance, and zero access code. So this remaining four topics we are going to discuss. So here it's like a practical. We will take one example and we do practical assessment of coding. Okay, we'll see that one also. So this is about mission coding. So I'm go through fastly because it is already done. Okay. So there is a Indian standards is there which we need to follow. Suppose some of the MNC companies is there in our organization. Suppose some of the people working in MNCs, then they has to have comply to the international standards. Or suppose if people are purchasing a equipment from the outside of India, then they need to comply this international standards also. Okay, so then we talks about the principles of machine coding. So the main principles of machine coding is prevent access and secure and tamper proof, and no new hazards because of that coding, and no interference. So even tip of the finger has to should not enter, and also it should not create any kind of interference in our productivity activities, and how to do safe maintenance. Okay, and ergonomics. Okay, so then we talks about the ergonomics of machine coding. So that is the easy of operation. Okay, and how to we need to adequate reach that one, safe distance has to maintain for that, and also noise control. Okay, and minimal strain and proper height and easy to access, and what we need to avoid: heavy guards, poor visibility, and workflow obstruction, and guard. So these things we need to consider. Okay. So this is another key topics, how this one machine coding reach has to calculate, consider for this. So there is always a reasonable reach curve is there, up to which section we should allow, and up to which section we need to plan how this guarding. And so types of machine guards. So again I will emphasize on this, so because this is very important. Okay, going forward. So there are four types of machine guarding is there. Okay, so that is fixed guards, interlocks, adjustable guards, and self-adjusting guards. Sometimes another is the distance guards is there, but the main four thing is the this one: fixed guards, interlock guards, adjustable guards, and self-adjusting guards. So in the last class I given on alchemy also. So that is a period. Okay, so that is one. So that is fixed guard, interlock, adjustable, okay, and grip devices. Okay. So like that you can remember these types of machine guards also. Okay. So you will get on question and examination point of view also, and in your day-to-day activities whenever you're doing any kind of assessment, machine guarding assessment or machine safety risk assessment. Okay. So then you keep in your mind this acronym: period, fixed, guard, interlocks, adjustable, and grip devices. So then comes to the fixed guard. So fixed guard is the highest protection level. So okay, this is have a highest protection and also it is a permanent barriers. So there is one machinery will be there, which permanently with enclosed with the guard, and it should be fastened, and no one will not approach this hazardous area. Suppose it is a rotating part is there, so some will not enter in this guard. Okay, it acts as a barrier, permanent barrier, and this is the highest protection level. Okay, so the permanent barriers with no moving parts and provide the best protection level. So this is the highest protection level. Suppose if you are want to plan any kind of, suppose if you are doing any kind of mission safeguarding assessment, no, then first of all we need to consider first if is there any fixed guard possibility is there. We need to look like that. So this have a highest protection level. So normally it comes with a sheet metal enclosures or wire mesh guards. Okay, like this. And second is the interlock guards, so where the people they have a minor intervention. Okay, suppose you have a minor intervention inside the machine, then these interlock guards are required. Okay, then these interlock guards are required. Suppose so there again, suppose there is one mission is there. Okay, so maybe one mission is there, it will revolve. Okay, then what happens, someone has to enter, maybe they do adjustment of you can consider some nozzle, or you can consider something, it may be anything. Okay, so they want to do some minor adjustment, it's not a maintenance related, so they want to enter in a minor adjustment. So then such cases, no, so then fixed guard is not at all practicable. So if it is not at all practicable to put the fixed guard here, because what happens once you put a fixed guard, it's like it fastened with a bolt and nut. So then fixed guard is not there. Then in such cases what we are doing, so we are doing some provided with a door. Okay, so we provided with a door provision kind of thing. So people what they will do, they will enter through this door, and they will do some adjustment. So during this also what happens, suppose one person enter inside. Okay, then someone will switch on the machine, there is a chances for accident, so there is a chances for amputation, such things are there. So in such cases what we are doing, in this such cases what we are doing, so we are providing a door interlocks, so where the entrance is there, no? So for this we are providing a interlock to the door. Okay, so like that. So this interlock guards, it's like if you want to do any kind of minor operation or minor intervention in your particular mission, so then these interlock guards are used. So guard connected to mission control, so we have a PLC is there, maybe safety relay, safety PLC is there. This interlock what is there, interlock to the mission, it got connected. So then what happen, if you open that, it disengages and switch off the power. Okay, so this got connected to the mission control. Mission stops when God opens and cannot operate unless God is closed. So such thing. So these are the interlocks. So normally we have a electrical interlocks, user switches and relays, and mechanical interlock. It's like a physical linkage. Okay, physic. Okay, physical linkage means mechanical interlock is nothing but, so normally what happened, we have a door is there, so you can this. Okay, so we have a door. Okay, this is a door, entrance door. Okay, so then we have a some kind of mechanical lock provision, like you can say your daily almara is there, no? Almara kind of thing is there, no? So what, there is a knob with key is there. Suppose that once here what happened, it got closed, then key will be you will get your key. But here it is means here it is different. So once it get open, okay, so there is a key is there, once this get open, then you will get a key. And what happened, this door will not get closed, because this what is the that lock provision is there, no? It's in open, it is in open condition and people will not close this door. Okay, so this is like a mechanical interlock kind of thing, and this is integrated with electrical interlock. So then comes to adjustable guards. So adjustable guards, it's like you can say where the lathe machine is there. So lathe spindle is there. For lathe spindle, we need to observe that, we need to measure the dimensions, we need to do monitoring kind of thing is there, no? So where here we use a adjustable guards. Okay, adjustable opening to suit different work sizes used where fixed guards is not feasible due to varying workpiece dimensions. So like you can say consider lathe machine and self-adjusting guards. So self-adjusting guards is nothing but it is automatically adjusted based on the workpiece size and position, common in woodworking machines. Suppose in I will show one example again coming slides. So we have an example considered on woodworking machines. So we will discuss this thing. Okay. So hope people understand about these guards: fixed guard, interlock, and adjustable guards, and self-adjusting guards. It's clear, right? Or any doubts? Yeah, thank you. Uh, so then finally, distance guards. So distance guards, it's nothing but a fence. Okay. So there is a one robo will be there. Okay. So then what happen? We'll provide a fence up to this what I can say affected zone. So where this robo arm can reach the up to that area. Okay. So we safeguard the people from this robo. So this is the distance guards. So physical barriers placed at a safe distance from hazardous zones based on the ISO 13857 safety distance calculations. Safety distance calculation is nothing but the affected zones up to which the robo arm reaches. Up to this, it will affect the people. Okay, in the vicinity, in that area. So the distance depends on body part, hands, and arms, full body, approach direction, and hazard type. So whenever you should calculate the distance, no, you should consider these things also. Okay. And comes to this types of guards is there, no, fixed guard, interlock, adjustable, self-adjusting, and the distance. So again, I said fixed guards is usually the highest. Okay, it is the highest safety we can get from the fixed guard. And next is I from the interlock guards, and adjustable and self-adjusting it is a medium, and distant guards is again it is I. So we have one standard it is there. So the standard is ISO. Okay, ISO it is international standard, not Indian. Okay, so IS 12100 is there. Okay. So in like our in our risk assessment. Okay. So in our risk assessment, we will do for each and every activity what is the hazard and what is the risk and everything. So here also we have ISO 12100 is there, one standard is there. So here in this standard also we identify the now what is the hazard in that and what is the risk level. Okay, these things will all consider. And when it comes to design requirement, design and selection of this one guards, so we need to consider this one. So whether it is strength and rigidity, okay, without operational forces and impacts, so whether it will create any kind of means it will can withstand that impact and rigidity and strength, that one. And suitable materials like steel, aluminum, polycarbonate selection. Suppose if we should have some kind of visibility, then we'll go for a polycarbonate kit, and it should be a lightweight, then we should be required some kind of rigidity, then we go for aluminum, like that. And impact resistance to impact and wear, and no sharp edges. We should not create any kind of other hazard. So for that reason, so we should consider no sharp edges for the guarding, and fire and corrosion resistance, material durability in environment. So in harsh environment, it should withstand that. Then selection criteria. So how we need to do selection? So criteria. 1 minute. So when comes to selection criteria, we need to see in our day-to-day operations also what happen whenever we need to do some kind of new job and everything. What we will do first, we start with a risk assessment, right? Right or wrong? Yeah. So that is a basic thing. So whenever you are suggesting anything, whenever someone will ask whether it is safe, you can simply say that I still not done a risk assessment. Once I do the risk assessment, I will give feedback whether it is in safer or not. Okay. Don't give any kind of hypothetical statement also. So and also for each and every activity, whether you are doing any job and everything, the first priority is risk assessment. So once you do a proper thorough risk assessment, okay. So in risk assessment, whether we call it is HIRA or job safety analysis or job hazard analysis or some companies they like last minute risk assessment, whatever it is. But so whenever you has to start any job, do the risk assessment. So like that, when comes to this guarding also, now what happened? We need to do a risk assessment. Okay, for selection and suggesting any kind of guard, so we need to do a risk assessment. So in this risk assessment also, so there is a standard I already mentioned, no? So ISO 12100 methodology. So this is a standard safety of machinery general principles for design, okay, risk assessment and risk reduction. So this is the standard you need to consider for this. So in this, what we will do, suppose yeah, I will take one example. That is the reason I bring this one. So this is a wood working machine. Okay. So this is a wood working machine. Okay. So it is a part of the syllabus. So now what happened? We need to make a risk assessment for this. Can someone identify the hazards in this machine? Identify the hazards. Yeah. So we should call it as a sharp edge. Okay. Sharp edge. Then it will rotate at a high speed, right? The sharp edge and high speed. Then any, so there is a suppose during cutting operation there is a some kind of ejection of wooden pieces. Wood piece will become, no, when during the cutting there is a wood piece will be eject or flying, I can say flying off. Okay, flying off wooden pieces, right or wrong? Or you have any questions, let me know. Okay, so flying of wooden pieces, so this is a hazards, right? So now we are identify a hazard here. Now, so now what happened? Now we need to assess the risk. Okay. So assess the risk. How estimate? A risk assessment. What happened? There is a likelihood into severity. Okay. So R is equal to likelihood into severity. So like that. Here also what happened? A rotating blade. Okay. This rotating blade is a high risk. We know it is create a high risk because so whenever finger something will contact this, what will happen? What happen? Finger contact this rotating blade means what will happen? Amputation, not cut injury also. It will straight away give a some kind of amputation. Okay, okay, to whatever it is. Even cut injury, it's a serious cut injury will going to happen. So it's not like a small cut like. So there is a means amputation means what? It is a considered as a high risk, right? So the cutting will consider as a high risk. Now we are considering this as a high risk because there is chances for amputation. Okay. So now what happened? We need to reduce the risk here. Okay. So we need to reduce the risk of this blade. Okay. So risk of this blade. Then what we can do? Yes, we are talking about guarding only. So yes, guarding has to provide. That is one. Okay. What type of guarding has to provide? Okay. So that is a question here. What types of Yeah. So what type of guarding has to provide? Okay. And is it design, by design we can do anything, that also we need to consider. Okay. Like first of all we need to consider the, okay, inherently this safe design means design by safety, we call design by safety. So during safety is during design itself we consider the safety. Like that we can make anything example. So this is a high speed rotating blade. Okay, so high speed rotating blade, so we can whether it is possible to do the low speed. Okay, that is example. So design by safety is nothing but instead of high speed rotating blade, whether we can go with a low speed. Okay, so like that we need to consider in this ISO 121. And also safeguards. Now comes to the guarding. So in guard, which guard, whether it is fixed guard is suitable here. Fixed guard is suitable, really? Okay, okay, you said fixed guard suitable. Now fixed guard means, now what happened, this and this I covered and I put a bolted net. Now it is possible to do the operation. Ah, right, right. Right. So it's not a fixed guard. We need to go with a adjustable guard. Okay. What you are saying that, so we will put a sides and this side and this side. Okay, fixed guard, and front side. You are mentioned here. We put one as a adjustable guard, right? Uh, so here we put a adjustable guard. So then with the interlock, door interlock. That is also fine. Okay, that is also fine. That is not a good idea. That is also good idea. Uh, but either here the thing is that, so we don't know the wooden piece size. Okay, how much it is, whether it is small, big, we don't know. Then what happened? We need to adjust this sizes also. Maybe we need to do setup. Okay. So everything that the size of the wooden piece has to change. Then we need to do a setup. But it's good idea. So okay, we need to provide a fixed guard around the three side and front side. We need to put a interlock. Okay. So that is one thing. And so here what happened? We use a three fixed guards and one interlock. Okay. And apart from this, so here we put a adjustable door. So adjustable door, that is a mobile door, it is there, and with a interlock. So here we totally put a fixed guard. Okay. So then you people mentioned a door, no? So that is a adjustable door, okay, front door. Okay, adjustable door or adjustable guard we can say, and interlock guard. So this is a three types of guarding we use for this simple machine. That is one. And apart from that, so we should provide these signages. Okay, warning signs. Okay, so there is a chances of sharp edge amputation will be there. I think you people are clearly seeing on the machine. So like that, we do this identifying the hazards and also risk assessment and doing the risk reduction in this ISO 12100. So if people have a time now, you can read this one. You get a knowledge on this. It will be useful to you. Yeah. So that's one. We'll go back. Yeah. So now what happened? Selection of the guard. Why we need to selection? I think by example you people got to know. So based on the type of the hazard, it is rotating, cutting, or thermal. We need to first of all we need to identify the hazard, then axis frequency. So how much time we are going to means like how much time we will enter inside a mission, how much time it will take for us. Okay, or how much time we need to do some kind of setup and everything. Okay, and where which area we will access on this. Okay, and operation mode, automatic, semi-automatic, and manual. So this one also we need to consider. And operator skill, experience or training level. and also maintenance requirement. Okay, so lubrication, inspection, repair needs. Okay. So it's got clear. So how to select the criteria for the emission coding. Okay, so first is hazard and access frequency. How many times we need to exposure to that hazard, okay. And also operation mode, automatic, semi-automatic, or manual, and operator skill, okay, and maintenance requirement. So these are all the things we need to consider when you are selecting a mission drawing. Okay. Apart from this, you need to consider means uh, how we need to select that one is the assessment we will do, and hierarchy of controls, and prefer engineering controls, physical guards over procedure. This thing has to do. It's got clear. And what happened nowadays? No, nowadays maybe where the this one automatic missions, automation missions or semi-automatic missions is there, where the interlocks are there. No, okay. So nowadays people are talking about modes of operation. Okay, not automatic, semi-automatic, manual. Is you whether any people heard about modes of operation? Modes of operation. Okay, so there is a modes of operation. Actually, whatever, it's a different subject. I can say it is a in-depth subject related to machine learning. Okay, normally we people will know the Lotto, right? Lotto we know. So Lotto we know. One. Then we know about fixed guard, right? We know about interlock, right? So this terms we daily we are using, and we know this. Whether you people know about interlock type, category 3 or 4, PLD or PLE, you heard these terms? Because why I am saying, I seen one of the industry, okay, one of the industry, I will not say more detail about that industry, okay. So in that industry, what happened, there are a lot of amputation injuries are there, lot of amputation, finger amputation will be there, okay. uh, so in that amputation injuries, what happened, they have a god, so they have one god is there, so and also they have one interlock, okay. So there is one god and there is a one interlock is there. So whenever they lift the god, the interlock get activated, and what happened, that machine gets stopped, okay. And below this one there is a one die is there, okay. So one die operation is there, okay. So people what happened, they sometimes they bypassing this interlock, okay. So they are bypassing this interlock sometimes by putting some object on this, or sticking with something, okay. And that is one. And second thing is that the interlock is there, no, the interlock performance is not such a extent, okay. Why means, if you know about this category 3 4 PLD or PLD, you get an idea. Okay. So what happens, people are normally what they will do, they think that whenever they lift the door, machine get stopped, okay. So that their idea. But sometimes what happens, this interlock getting malfunction, or this interlocks getting bypassed, they are lifting this one, okay. Then they thought that whenever you are lifting this, then a machine gets stopped, and they can remove the jam, but it's not stopping. People are placing their hands in between two die, and there is a amputations are happening, okay. So that is one. But you people should know about the modes of operation. So this is a we talks in OSHA, not in India, it is there. Okay, when it comes to OSHA, there is a four modes of operation: mode 1, 2, 3, and 4. Okay, when it comes to mode 1, it is like normal operation. So suppose, so there is a one mission is there. Okay, so you are operating outside the mission. So there is one HMI panel is there. You are operating here. So you are not at all exposing to the mission. So that is normal operation. That is mode 0. Okay. So here what happened? There is no interaction with the hazard. And mode 1. So mode 1 it's like a minor intervention. Okay, minor intervention, but partial body. Suppose what happened? So I want to adjust in this mission. Now what I will do? I will so I want to do some adjustment here. Then what happened? There is one door is there. Okay, I open the door. Then I will do adjustment. But I will not enter inside the mission. Maybe I will enter here by putting my hand. I will do adjustment. For this, normally what happened? So there is a one adjustable door is there. For that interlock is there. Okay, but this interlock, what is the interlock? It should be there. No, it's not like a photo electric like one reflector will be there. It should not not like that. Okay, it should be a category 3 or 4. So category 3 or 4 is nothing but it is like a highly performance device which have a dual channel safety circuit. Means uh, see, if you people are not understand, no, let me know. I will explain in detail if required. Okay, so normally what happen for every mission, no, there is a one input. Okay, you will give an input. There is one logic is there. Then there is a output is there. Okay, means if the door open, mission gets stopped. That is the logic, right? So now when comes to this category 3, what is there? No, here dual channel is there. Dual channel means here two circuits will be there. Okay, so we have, instead of one circuit, we have a two circuits. Okay, the two circuits what happen? We will normally be called a safety PLC or dual channel circuit. Okay, so these circuits what they will do? Suppose this get bypass, no, this will activate on. It is very difficult to bypass these devices. So that is the reason we are going with a category 3 or 4. This have a separate safety PLC in that control panel. Okay, so that is one. When comes to mode 2, mode 2 is the full body entry. Full body minor, for minor intervention only, full body entry. Full body means person will enter inside the mission. So he will enter inside the mission, but here he will open the interlock. So one is interlock will be there, and second is the mechanical key. Mechanical key will be the mechanical key. Okay, or trap key we will call. Okay, so what happen? He will go with a some key. Okay, so this key what happen? It act as a some locking mechanism. No one should not close this door. Okay, so such a kind of system will be there. So that is for the full body entry. Okay, and mode 3 is nothing but a lotto. You people will know. So whenever you are doing that door, so entirely we are using this lotto. And mode 4 is nothing but a you people will do some kind of trial runs and verification, no, with the power. Okay, I can say jog mode also. So this comes under mode 4. So when mode 4, what happen in jog mode you will do. So ensure that the jog is have a two hand operation. Okay, two hand operation, not in a single hand operation. So this comes under modes of operation. So you people while doing the risk assessment also ensure that what type of modes of operation that activity, and what type of mission guarding is there, and what type of interlock should be required. Okay, this you people has to ensure. It's clear. It's a very big subject, but at least you remember this one. So normal operation, minor intervention, partial body, it should have a door interlock. Okay, that is category 3 or 4. And for the mode 2, full body entry. For full body entry, it should have an interlock and also mechanical key. So what will happen, suppose one person was inside, if not someone will seen him, no, then what happen, they will close the door and switch on the machine, then accident will result. Okay, so to avoid that, we should have a this mechanical trap key. Okay, and mode 3 lotto, you people know that. And mode 4 is a power. So during startup or during some kind of trial run or some kind of validation, whatever we need to run in power, like in jog or with low speed. No? So that all comes under in mode 4. So in mode 4, what happens? So we need to carry out under outmost supervision, or if suppose you are using a jog mode, then we should use a two-hand control operated jog, and the speed should be in a less. Any doubts is there? I think this is very big subject, but a brief. Yes, yes, it is there. PLD and for light curtains, but this light curtains is there, no, light curtain sensor. You should not consider for the men entry. Okay, so light curtains normally not designed for the like a for minor intervention operation. It's designed for the what I can say, that product entry, exit, such kind of thing. Okay, but you should rely on this minor intervention. But light curtains have this PLD and PLE also. Right. So when it comes to machine guarding, woodworking machineries, so hazards are high speed cutting tools and kickbacks and flying wood chips. Okay, so these are the hazards. And precautions, comes to precautions, we have a hood guard for circular jaws. So hood guards is nothing but a, so there is a one adjustable enclosure will be there. Okay, so adjustable enclosure will be there. And also revining knife. Okay, revining knife will be there like this. Okay, what happen if the piece or something, it pull, it will stop here. Okay, and kickback means, suppose if you are placing one wood piece, sometimes what happen, it will harden surfaces, it will create some kickback. So for avoiding this, so here we put some kind of anti kickback fingers and self adjusting guards. That is, the hood guard is, itself, it is a self adjusting. So whenever the wood piece is high size and this one. And finally we should have a this push sticks or push blocks to hold the workpiece. Even though something goes wrong, it should not create any kind of accident to the fingers. So like this. So this is a foot guard. So it will place on the saw. Okay, and also it acts as also adjustable guard based on the workpiece. Okay, whenever workpiece size increases, it will also act as adjusted accordingly. And reviewing knife. Okay, so reviewing knife, this is a reviewing knife. And this is an anti kickback box is there, no, the teeth is holding the job, so it avoids the anti kickback. And this is the push sticks and push block. So like that, what happened, you people has to write the mission guarding requirement for the each and every equipment. Okay, so I given a brief on this, but go through your company, where your organization, where you are working, take one, consider one mission. So you do a validation on that. So whether this is comes under fixed guard or interlock, and whether that guard is sufficient, based on the, again, you consider based on the type of the hazard, based on the frequency. Okay. So when it comes to syllabus, we have woodworking mission. I already explained on that. Then paper and pulp missionaries. So paper and pulp missionaries, we have in running dip point rollers. So in paper, what happened? So there are different rollers will be there. Okay, there are three rollers, or okay, three or four eye rollers will be there. In that paper will roll. Okay, So the main issue here is the one is that there is a chances of entanglement and it leads to crush or amputation will be there. In I worked in one of the tire industry. In that we have a winding machine is there. Okay, it's like this winding machine is there. It will wind the fabric. So this winding machine, what happened during lunch time now? Only there is a production delay is there. That supervisor asking, he hold the one of the operator during lunchtime and ask him to do the winding. Okay, so during winding, what happened? This guy got entangled. Okay, so there is no someone not watched that, so then it leads to like a fatal accident. So is you normally we people also seen some videos now. So what happened, this person got angle and his head repeatedly hit the surfaces, then it leads to a fatal accident in this situation. Okay, so suppose if you are working in a paper or pulp industry, okay, where these rotating objects, nip points, rollers are there, then you need to consider about the fixed guards. Okay, if fixed guards are not possible, then you consider with the interlock guards. If interlock guards are not possible, then you can go with the trip wires. Okay, we can call it a pull cord switches or pull cord wire is there. Suppose someone will be there, hit at this one, no, it immediately stop the machine, like the trip wires or emergency stop. And also if the nip points is there, it's possible to the guard that one, you go with the nib guards. It's nothing but a fixed guard, but you here it clearly mentions the nib guard. You consider that one. So okay, can you someone explain why push button, okay, and emergency stop, e-stop is different? Why? So emergency stop is not normally what happen. It will emboss outside and it have a, some kind of mushroom kind of thing, right? Emergency stop, right or not? Uh, so normal push. Yes, yes, please. Why the difference? Push button and emergency stop. Uh, okay, okay, fine. Then any clear understanding? See, normally what happen? The push button. Okay, push button. What happen? We have a push button. It is like in normally it will below the HMI panel or level of the HFI panel. So here we need to press with the finger. It will stop or it will on. But when it comes to emergency stop, it is different. Why emergency stop is different is, suppose in this case, same in this roller case. Okay, so there are some rollers is there. Okay, some two rollers is there. I am doing some feeding. Maybe I am doing some answer pack. My both hand got caught. Then how can I switch off the push button? Not possible, because so my fingers both are caught in this roller. Then this emergency button, what happened? Can I stop the emergency by pressing with my head? Okay, by pressing with my shoulder, by pressing with my body, I can stop this. It's right or wrong? Understood or not? So in this push button, what happened? In push button, we can do only with fingers. Okay, push button only we do can with fingers. But emergency stop, it is different. If fingers got caught, then we need to stop this. By by your body, by your shoulder, by your head, by your leg, whatever it is there. But push button is different. Emergency stop. Okay, so that is the reason emergency was in a, it like embossed outside and should have a very big in size. Okay. So that is the main purpose. But okay, we should consider it. But some industries, no, I will see that this emergency stop also got it. They beautifully they put on cover. When I asked them why you put it, they said that sir, someone on the way walkway they will touch it and machine gets stopped. The purpose is that is only if someone unable to reach that area, any body part has to touch, it will get stop. Okay. So this is the main difference between the push button and emergency stop button. Okay. In your company also see this. If any guard is there, remove that for emergency stop. Okay. Like that. And rubber and plastic machinery. So here mixing mills, calendars we have similar to tire industry. And what is the here the trip boss? So when someone got entangled, trip boss should activate. And pressure sensitive devices. Pressure sensitive device is nothing but the area. Suppose here the roller mat is there. Okay. Okay. So whenever you enter these devices, these rollers get stopped or reduce the speed will be active. So that is a pressure sensitive area where the highly hazardous area or the highly risk prone areas will install this pressure sensing mats on interlock guards. So we will put some adjustable guarding, and whenever we need to remove or whenever we need to do some operation, we put a interlock guard for that. Okay. Then printing machineries. So printing machineries, rollers and cylinders, and inking mechanisms. Here the fixed nip guards and interlock guards is there, interlock covers, and emergency stop guards, that is full guard ropes and everything. And finally comes to the mission tools like lathes, milling and drilling. Here rotating chuck, flying chips. So this is the main hazard. So for precautions, what we have here, chunk guards is there, transparent polycarbonate shields we have, and interlock doors. So interlock doors we have for the CNC or lathe or drilling. So this is about guarding of different types of machinery. Um, in chapter 2 also some of the missions additionally given some of the missions, but I will skip that. You people go through that. If you have any doubt you can come, because again it creates some kind of duplication of class. That is the reason. So you can people consider that as a homework and assignment, whatever it is. Go through that in second chapter. They given safety in use of missions like that. So go through that, so do that, and okay. So now come to the key thing, that is built-in safety devices. So built-in safety devices. See, we will talk one thing first. So there is one screw press is there, extruder or screw press. You can consider, no, screw press. There is one screw is there inside. We have one chute. Okay. Normally this chute, what happen? It will rotate like this, right? You seen this extruder or screw press? So normally we'll feed here, it will get mixed and it will come outside, right? So in our in our day-to-day activities or some videos, we will see that someone place his hand here, okay, inside, and feeding it, hand got crushed or amputated, whatever it is, it happens. Okay. Now these built-in safety devices is there, no? They are made, designed by safety by design. So now what happen? There is a chances of hand get entangled with this screw press. Now what I will do as a safety professional, when I do this risk assessment, I will increase the chute. Maybe you can consider 1 meter or something. Now is it possible to place hand here, contact here? So at this level, he able to place his hand in the screw feeder. Now, but what I done, I increase the chute height. Okay, I increase the chute height. So even you try to contact this also, it is not at all possible, because the chute height is very big and is unable to contact this surface. Okay, so like that, we need to do safety by design. These built-in safety devices are considered like that. Okay. So these are the emergency stop buttons and also two hand control devices, right? Suppose what happened, there is a screw press is there. If there is only one hand control, what normally person will do, he place one hand here and you do operation. There is some misalignment, then it will got crushed in it. So for that reason we will give a two hand control. So while pressing the both hand only, the press will move up or down. So this is another built-in safety devices. And light curtain. So this is a safety barrier detections. Whenever someone enters the danger zone, it will detect and it will stop. And pressure sensitive mats again. So whenever there is a danger zone is there, this mission is very dangerous, someone should not enter, then what happen, we will put this pressure sensitive mats, it will detect and it will stop. And pull cord rope and trip balls. Suppose this there is a one rolling machine is there. Okay, so there is one rollers is there. So two rollers is there. Suppose I am feeding this. So suppose it got entangled. Then what happened? There is one full cord. Okay, a trip bar is there. No? Trip bar. If something contacted this by heat, by my body, my hand or something, the machine gets stopped. Okay. So this is about full cord or trip bars. So this related to built-in safety devices. Always consider this is safety by design. So whenever you are designing some machineries, whenever you are doing some risk assessment, so always look about this one. Okay. And comes to maintenance, so regular inspection has to do for the this guarding, because people will try to bypass this interlock guards, remove the fixed guards, or after doing the maintenance they will not refix the guards. Okay, so then check the interlocks and fasteners, lubrication without removal. So again, so if you locate the lubrication points outside the machine body, not inside the machine body. If inside the machine body is there, people try to remove that lubrication points. That is one. And replace the damaged parts. So replace the worn guards or rusted guards. That one. Okay. And safety during maintenance. That is mainly it will comes to Lotto. That is mode 3. Okay, so during maintenance go with a Lotto, okay, or Lotto 2, whatever is your organization. And formative work system and temporary remove guards, because if you are removing the guards, then Lotto has to apply and follow the format system. And this is a final topic, zero axis guarding, the ultimate protection. So zero axis guarding, normally it called as a 360-degree guarding. Okay. At any side, any physical interaction with the hazard not possible. So that is 360-degree guarding. Okay. So zero axis guarding ensures that physically impossible for any part of the human body to reach the hazardous zone during normal operation. So that is fully enclosed missions. So total enclosed missions, one thing, and interlocked access door, second, and automated feeding and unloading. Okay, so it carry out the automatically feed, and it will do the automatic unloading of that. Okay, and this zero axis guarding should comply ISO 13857. So for the safe distance of robots, okay, to maintain the safe distance, how much safe, normally suppose there is a one missionary is there, whenever you are done a guarding, no, the minimum requirement height is the 2.2 meter. Okay, and bottom to this guarding, if there is a gap is there, it should not maximum 150 mm. So this kind of things we need to consider. Why this zero axis guarding is, it have a highest protection level, eliminate human interference difference, and support industry 4.0 automation. Now our automation, this one industry support is a 4.0. So that's it. For this automation level, zero axis guarding will be the give the ultimate protection. So that's it. Any doubts you have?